Hey everyone, we're going to get into reviewing roots next. In general, I just want to say as we get going that roots are very much defined as an inverse operation. They're the inverses of our powers. So it's the inverse of squaring or cubing or raising to the fourth. And inverses are a big deal. They're going to be an ongoing theme through this class with inverse operations and through pre-calc 1 and 2 with inverse functions. And then Calc 1 and Calc 2 are entire classes dedicated to doing something and then doing its inverse. So this is a really big deal. You'll find it everywhere in math. If we figure out how to do one thing, we want to figure out how to do the opposite or the inverse of that thing. We've been using this to solve equations like crazy. If we have a +7 in an equation, we use the inverse operation and subtract 7 from both sides. If we have a ×5, we'll use the inverse operation and divide both sides by 5. So we're just kind of continuing that here. So I just want to frame it in that way. Hopefully we've all dealt with roots before and we're just refreshing our memory and again, maybe getting a chance to practice some memorization if needed. The memorization is kind of the same as that you've done with the squares and the cubes that you're working on, so hopefully that helps. And roots are also included in the Kahoot that I linked, I think, within this assignment for you to use as extra practice. So if we're defining the square root of x, we say that the square root of x is the number that you square to get x. So if we take whatever that is and we square it, we should end up with x. Or another way to say that is that square roots and squaring are inverses. So if you apply one right after the other, they cancel each other out. Similarly, the cube root of x represents the number that you cube to get x. So if we take the cube root and cube it, we end up with x. And again, you could say that as their inverse operation. So if you cube root and then cube, or if you cube and then cube root, even though I didn't write it that way, you should get back x. Same thing with fourth root. We're going to be thinking, what do we need to raise to the fourth power to get x? And in general, the nth root represents the number that you raise to the nth power to get back x, whatever's under the root. So again, powers and roots are inverse operations as long as the index, that n, matches on the two, and as long as there's nothing extra happening in between them, like a multiplication or an addition or something like that, they should cancel each other. So to run through here, once again, you should be trying to memorize your perfect squares up through 12 squared. And with that, you should then know the square roots up through 144. Because when I look at this, I say, what number do I square to get 144? And if I've got those perfect squares memorized, I know that that's 12. I did have notes along the way, and I didn't really remember to point it out as we were there. With the even roots, there's really two possible answers. If you're asking yourself, what do I square to get 9? The truth is that you could square 3, or you could square -3. So there's always a negative and a positive answer. But that's really only ambiguous if you write it as a square. So if we write it kind of how I did there, we say x squared equals 9. Then there are two possible answers. We'll get to that really soon. We're going to be solving equations like this very shortly. When you're given the root will tell you if it's positive. So if you get the square root of 9, that is +3. And if you get the negative root of 9, that is -3. So there is no ambiguity when you are asked to find a root. The one thing we do have to be careful about is that we will have problems finding the square root of negative numbers. If I'm asking myself, what do I square to get -144? The answer is that I can't do that. As soon as I square something, it becomes positive. So this is impossible. There is such a thing as imaginary numbers where we define something to represent the square root of -1, and some beautiful and amazing math comes out of that, but that is not useful for the purposes of this class. We're working on real numbers only, and if you need imaginary numbers, they will come up for you in the future. So here we would say undefined or not a real number. For my open math purposes, probably DNE does not exist. That will be great. I would say the most accurate answer is really not a real number, but DNE will work beautifully. Okay, and again, with that side note, this is asking for the negative root of 144, so that will be negative 12. So it should be very clear whether you're asking for a negative or a positive, and if it is an even root, a square root, a fourth root, a sixth root, etc., you cannot take the even roots of negative numbers. Okay, next on my list, oh, and I've got more down there, let's show them all, is negative root of 64. So again, there's the memorization piece in here. Let me switch colors. The root of 64, square root of 64 is 8 because 8 squared is 64. So you ask yourself the square in question, and this is asking for the negative root because it's also true that negative 8 squared is 64. So that is our answer. 64 is kind of a neat one because it is a perfect square, but it is also a perfect cube. So again, it is helpful if you've memorized some of those perfect cubes, but if you haven't, or if you did and you forget, you can trial and error these fairly quickly. I'm not going to ask you to cube or cube root big numbers, so you can just kind of start at the bottom and say, well, 2 cubed is 2 times 2 times 2, which is 8, and 3 cubed is 3 times 3, which is 9, times 3, which is 27, and 4 cubed is 4 times 4, which is 16, times 4. This is getting bigger already, so I'm writing it down, and that is in fact 64. So if 4 cubed is 64, then the cube root of 64 is 4. So this back and forth, it's mental gymnastics. It's a little tricky at first, but that's what we're going to do, is work with both powers and roots, and we want to get comfortable with both. Last one is the fourth root of 81. And again, I'm not going to give you a real big number, so if you need to, just try it out. 2 to the fourth is going to be 2 times 2, which is 4, times another 2, which is 8, times 2, which is 16. Not big enough. 3 to the fourth is the same as 9 times 9, which is in fact 81. So the fourth root of 81 is 3. So you can reverse engineer this if you don't have them memorized. That's completely fine as long as you're comfortable doing that number crunching. If you're not so great at it, keep practicing. It'll stick soon. Okay, and one more. I'm not going to be asking all sorts of crazy seventh roots and things like that. But the one thing that's fair game, in fact, 2 things, are 2s and 10s. We should be able to raise those to fairly high powers. So it's a pretty good guess if you have a big old root that it probably is a 2. Let's try it. 3, 4, 5, 6, 7. So 2 times 2 is 4. Double that is 8, 16, 32, 64, 128. So it is in fact true that 2 to the 7 is 128, which means the 7th root of 128 will be 2. So that's the kind of arithmetic I expect you to be able to work with. I know it can be a lot if you haven't had to do that, but it's really important that we can crunch these without always having to go back and check or use technology. Okay, cube root of negative 27, where it was impossible to take the square root of a negative number, it's totally fine to take the cube root of a negative number. We just checked right above this and found that 3 cubed was 27, so let's try negative 3 cubed, which means negative 3 times itself once more. Negative 3 times negative 3 is 9, and then if we multiply that by negative 3, we do get negative 27. So the cube root of negative 27 is negative 3. So if you take an odd root of a negative number, you're just going to get a negative answer. That's very doable. Last on this list is the negative fourth root of 16. 16 is not a very big number for a fourth power, so I think I'll guess 2s again. And that actually looks really promising because 2 times 2 is 4. And if I do that twice, I get 4 times 4, which is 16. So the negative fourth root, see if I can say it right, of 16 will be negative 2. Last row, we can do this with fractions. We're going to study radicals as their own entire topic later, roots, but I want to bring this one up right now. You can absolutely do this. If I'm asking myself, what is the square root of 1/4? That's the same thing as asking, what do I square to get 1/4? And it might mess with you at first, but that 4 is a perfect square and you can use that. What I need is 1/2 times 1/2 to get 1/4, which means that 1/2 is the square root of 1/4. One of the properties of roots that we'll get to is that you can split them over multiplication or division. So here you could split that into the square root of 1 over the square root of 4, but you don't even have to go to that length. You can just go back to the real basics of what does it mean to be a square root. It means that if you square it, you get that number underneath. Negative root of 25 over 81. So we know we want the negative one. And if we want to square something and get 25 on top of our fraction, it better be 5. And if we want the 81 on the bottom of our fraction, we better have had a 9, so that when we multiply by itself, that's what we get. So if 5/9 squared is 25 over 81, then the square root of 25 over 81 is 5/9. Okay, and last but not least, it's completely fine to take the cube root of a negative number. We will get a negative answer. We want to know what number can we cube to get this 8 over 1,000. We've already dealt with the negative. If we want to multiply 3 of the top together and get 8, that top better be 2. So when we do 2 over whatever times 2 over whatever times 2 over whatever, we get the 8. And if we want a number that we multiply by itself 3 times to get 1,000, we're probably going for 10. 10 times 10 times 10 is 1,000. So it really does mean the same thing as up above. 2/10 times 2/10 times 2/10, which I realized I was sort of silly here. I made you one that could reduce. 2/10 is really 1/5, and 8 over 1,000 could have reduced down as well and been 1 over 125, I think. But that's fine. We'll just stick with it. I was a silly teacher, and we'll just go with the thinking there. So negative 2/10, or again, great if you recognize that and make it a negative 1/5. Okay, so hopefully that helps. This is kind of boring to watch, but hopefully some of the explanation in there helps this click so that you can figure these out. Thanks for watching.